So hello everyone, today we're going to have test of hypothesis for single samples. The course outcome that would be considered today would be the application of statistical methods in the analysis of data. What is type 1 error? The probability of type 1 error is designated by alpha. So alpha is the probability of type 1 error, which equates to the probability of rejecting the null hypothesis when in fact it is true. So sometimes alpha is called the significance level or the alpha error or the size of the test. Considering the propellant burning rate example, we have identified that the mean is really indeed 50. So we have the mean is 50 and our critical value would be 48.5 and 51.5. If it is falling below 48.5 or greater than 51.5, that would be the critical region. So we commit type 1 error if it is true that the mean is 50, but the computed sample mean falls below 48.5 or greater than 51.5. So suppose that a standard deviation for the burning rate is 2.5 per second, and that the burning rate has a distribution of a sample mean is approximately normally distributed with mean 50 and the standard deviation of all the samples sigma over square root of n, so that would be 2.5 over square root of 10, which is approximately 0.79. The probability of making a type 1 error is equal to the sum of the areas that has been shaded in the tails of the normal distribution. So alpha is the probability that x bar is less than 48.5 plus the probability that x bar is greater than 51.5. In order to compute for the p-value or the type 1 error, the z-values that correspond to the critical values 48.5 and 51.5 are z1 would be 48.5 minus 50 over 0.79. And for Z2, it would be 51.5 minus 50 over 0.79. So therefore, we're looking for the probability that Z is less than negative 1.9 and plus the probability that Z is greater than 1.9. So take note of this value. We're going to have this on the next videos. So the probability is 0.0574. This is alpha for the probabilities greater than, for n is 10 and from 48.5 to 51.5. So this implies that 5.74% of all the random samples who lead to rejection, the hypothesis H null is equal to mu equal to 50 centimeters per second when the true mean burning rate is really 50 centimeters per second. We can reduce alpha by widening the acceptance region. So say for example, instead of 48.5 to 51.5, we extend it a little bit by zero point 0.5. So alpha would be the probability that Z is in between 48 and 50 or outside 48 and 52. So it would be Z less than 48 minus 50 over square root of 0.79 plus the probability that Z is greater than 52 minus 50 over 0.79. So the value now would be 0.0114. So observe that as we widen the interval, decrease, as we widen the acceptance region, we decrease the critical region or we decrease alpha, the type 1 error. So decreasing type 1 error decreases the p-value, which is now 0.0114, coming from the original value 0.0574. If we will be increasing the sample size from 10, we make it 16. So the resulting sigma over square root of n would be 0.625. So the computed value of z1 and z sub 2 would be negative 2.4 and positive 2.4 respectively. So if we are going to solve for alpha, that would be the probability of z less than negative 2.4 plus the probability of z greater than 2.4. So coming from the original value of 0.0574, when we increased the sample size from 10 we made it 15, from 10 we made it 16. So the original value of 0.0574 becomes 0.0164. So the probability of committing type 1 error decreases when we have a bigger sample. So when asked for the sample size, always increase the sample size so that we can decrease error. So let's consider type 2 error. So type 2 error is the probability that uh, we fail to reject the null hypothesis when the null hypothesis is false. So beta is the probability of committing type 2 error. So for the probability of committing type 2 error, uh, we are going to have a different mean. So what we're going to do will be calculating the probability of type 2 error. The normal distribution is on the left in figure 9-3 is the distribution of the test statistic x bar when the null hypothesis HO is equal to mu equal to 50 is true. And the normal distribution on the right side distribution is when the alternative hypothesis is true and the value of the mean is 52. So the z values is corresponding to 48.5 and 51.5 when mu is equal to 52R. So negative 4.43 and negative 0.63. So therefore, the probability that C is in between negative 4.43 and negative 0.63 is approximately 0.2643. So this is our beta, 0.2643. The probability of making a type 2 error increases rapidly as the true value of mu approaches the hypothesized value. For example, where the true value of mu of the mean is mu equal to 50.5 and the hypothesis value of HO is mu equal to 50. So the z values corresponding to 48.5 and 51.5 would now be negative 2.53 and 1.27. So beta would now be 0.8923. So this significantly increases as we go closer to mu. So the probability of committing type 2 error increases when we go close to the true value of the mean. So if the sample size is changed from 10 to 16 like what we have earlier, so z1 would now be negative 5.6 and z sub 2 is negative 0.8. So coming from the original value of 0.2643, the new value of beta would now be 0.2119. So increasing the sample size results in a decrease in the probability of type 2 error, which is not that wide. So these are the references for this